Hi, my name is Bryan Barksdale, and I'm a PhD student at the Virginia Institute of Marine Science, where I use chemistry, sediment cores, spatial analysis tools like Google Earth, and online modeling to answer questions about how carbon and sediment transport across the coastal landscape connects individual ecosystems like salt marshes, mud flats, and barrier islands. So I made a lesson plan called Manager's Dilemma, Defending Salt Marshes Against Rising Seas. And this lesson plan requires your school to be a Google school so that students have access to the online materials only available through Google. It's aimed at advanced environmental and computer science students and fulfills Virginia Science Standards ES1 and ES6. There are 5 components to this lesson plan shown here. All of these are available for downloading on the Virginia Sea website or through a link accessible in the teacher's lesson plan document. And I want to briefly walk through the structure of the lesson and how these components work together. So the overall goal of this lesson is for students to act as restoration managers for a struggling salt marsh and to make decisions about how best to restore the marsh based on the ecosystem services that people in their community value the most. So for example, if people in the community care most about fish and bird habitat that the local salt marshes provide, then student managers should choose the restoration strategy that maximizes marsh habitat area for those animals. Students will use an online modeling tool to help them make these informed decisions. And this model uses sea level rise rates and other model inputs to show how ecosystem services of a salt marsh that does or does not receive certain restorations may change over the next 150 years. So the PowerPoint provides background information necessary for students to complete the modeling activity, and it should take around 25 minutes to review with your class. While this is a lengthy introduction to an activity, the PowerPoint continually engages students by asking them questions that they have to answer on their worksheet. So the PowerPoint covers the topics that are listed at the top of this slide. And I want to show you that at the end of the PowerPoint, you as the teacher would walk through an example with your students. So we'll look at that example as well. So let's review the activity. So for the activity, students are paired with 1 to 2 partners. They'll answer questions 5 through 9 on their worksheet with their partner, and then they'd select which of 4 marsh sites they want to manage, choosing between California, Louisiana, Virginia, and Massachusetts. Once they've selected their site, you should give them their site handout that informs them about the marsh that they've chosen to manage. So this is what that handout looks like. It shows the rate of sea level rise, the rate of erosion, and how much sediment is in the water, which is also called the suspended sediment concentration at their site. It also tells them which ecosystem services community members value the most. And these ecosystem services reflected in the pie chart should be the ones that the students as managers are monitoring for and are making decisions based on. So in this example, which is the same one that you'd walk through at the end of the PowerPoint, the community members value the water quality benefits of salt marshes the most, and then second most, they value the storm protection that the salt marshes provide. And then the text on the lower right tells them what characteristics of the marsh they should be monitoring for based on which ecosystem services were most valued. So because the community cares most about water quality benefits of a salt marsh, we know that salt marshes actually improve water quality by absorbing excess nutrients in the water, and therefore the students should monitor nitrogen uptake by the marsh. Once the students have chosen their marsh site, they should toggle between 3 things: the instruction guide, their worksheet, and the online model. The instruction guide walks students worksheet question by question through the use of the model because it can be slightly tricky. And then the worksheet is available in 3 different versions, 2 of which are computer-based. So they could use it as a Google Doc, and all of these are available for downloading. A Google Doc a Microsoft Word doc, or as a printable worksheet that they would fill out by hand. So I recommend having your students fill out the worksheet as either the Google Doc or the Microsoft Word doc. And the Google Doc, I think, is the easiest since they'll already be using Google. But both the Microsoft Office Doc and the Google Doc have interactive features like drop-down menus, and they allow students to copy and paste the graphs that they generate in the online model. And this is not possible if you print the worksheet and have them work it out by hand. Okay, to use the online model, you need to provide students with a zip file containing all the data. This is called virginiac.zip, and this is available for download on the Virginia C website. Students should upload the zip file containing all the data to their Google Drive. They could do this at the start of the lesson or after you've already reviewed the PowerPoint. And as it says at the top of the model, the zip file should be stored in their main Google Drive, not in a subfolder. After reading the other instructions at the top of their model, students can start to play with the model. They will need to hit all of the permission buttons that pop up so that the model can access the data stored in their Google Drive folder. The worksheet eventually asks them to select the site conditions of the marsh that they're managing for, and I'll follow marsh site number 0 for the purposes of this video, which again is the same one that you'll review with them at towards the end of the PowerPoint. So this marsh site has a sea level rise rate of 4 millimeters per year, average erosion rate of 4 meters per year, and a suspended sediment concentration of 30 milligrams per liter, which is relatively high. Okay, so now let's go to the model. You would want your students to read these instructions at the top and then select the site conditions for their marsh, which I've already done for this example using these drop-down menus. I've preloaded this sea level rise curve because it can take up to a minute to generate, which it says here, and you may have to remind your students of this. And then the next set of questions relates to the worksheet questions about where within the tidal frame, which is the range between low and high tide, marshes typically grow. So students would use these graphs to answer those questions. And then continuing down the model, every time pressing this black play button, we see that the next section allows students to choose which restoration they want to implement. And so they have 4 choices. They could do no restoration by not selecting either of these. They could choose to implement the sill, the thin layer placement, or both. So now let's do just the no restoration scenario, because I want to show you the elevation profiles, which is the next graph that is produced. Okay, so we'll say create elevation profile. And so this graph depicts the change in elevation between year 0, shown in blue, and year 50, shown in orange, of a marsh that receives no restorations. So by comparing the starting elevation with the one at year 50, we can conclude that the marsh has suffered from edge erosion of about 200 meters. And here the green text box can give more information explaining trends in the graphs, and students especially may have to rely on the green text boxes for certain trends that aren't as intuitive as others. Okay, now let's turn on the sill, and anytime we go to a previous step in the model, we need to clear the following results and then rerun. So we're gonna generate another elevation profile, and then I want to show you the last steps of this model. Okay, so we see something quite different this time. And now we're gonna go down here, and we're going to choose to track the ecosystem services that the community members valued the most. So we said they valued water quality, so we're using nitrogen uptake as a proxy for water quality. And then second most, they valued storm protection. And so we can use marsh width as a proxy for how much storm protection the marsh can actually provide. Finally, you'd want your students to click the show control and restoration, so we compare what the marsh that receives the restoration versus one that doesn't, so we can compare those two. And finally, we will generate our graphs. So here we're looking at how the marsh width changes. So marsh width on the y-axis and change over time on the x when we compare the marsh with a sill versus one that does not have a sill. And then in the graph below, we see the nitrogen uptake rate of the marsh with the sill versus without. So the cool thing about using a Google Doc or Microsoft Office doc worksheet is that students can come here, copy the image, and then go to their handout. Here we're looking at nitrogen uptake, and we're just looking at the sill compared to the no restoration, and we can paste that graph in. Okay. So finally, they'll answer questions. Oops, I'm gonna go back to the slide. They'll answer questions related to the graphs in this rightmost column. And this is a slide taken out of the PowerPoint that you would show your students. And then you could give them an example answer that you may be looking for when comparing these two graphs. Okay, at the end of the lesson plan, students will have to make a case for which restoration strategy is optimal for their site, defending their judgment call using the figures that they've produced. Okay, that's it. Thank you so much, and I hope you and your students enjoy.